In this lesson, we're going to write fractions in what's called simplest form. Sometimes in instructions, in lessons, the author will say, write your answer in simplest form. And in some language, that is called reduced to lowest terms. But the author of your book will say simplest form. There are some examples here. Suppose this represented a candy bar right here, and it was broken into 3 pieces, and one piece was what you were looking at. That would be exactly the same amount as if the candy bar were scored into 6 pieces, but you were looking at 2 of those smaller pieces. 1/3 and 2/6 are considered equivalent fractions. They're the same amount, different names. The 1/3 is the simplest form. It is also shown over here on a number line. And a fraction is written in simplest form, simplest form or lowest terms when the numerator, top, and the denominator, bottom, have no common factor other than 1. And then there's a little note that says sometimes the prime factorization is a helpful way to find common factors. Now, I'm going to take a minute before we look at our examples. Suppose I have the fraction 12 out of 18, and I ask you to write it in simplest form. There are 2 ways that you can do this. One of them is kind of a brainstorming technique, and it's difficult to teach. If you understand it, it's great. But in this brainstorming, you're going to look at the number 12, look at the number 18, do a little thought, and say, is there a number that goes into both 12 and 18? The answer might come to you, if you're good with your multiplication facts, that the number is 6. If I take 12 and divide it by 6, I get 2. If I take 18 and divide it by 6, I get 3. 2/3 is equivalent and simplest form for 12/18. That is a brainstorming technique. Works very well if you came up with the number 6. But let's say you kind of stalled out once in a while and you couldn't come up with the number. Then you might use prime factors instead. You could take the number 12. Prime factorization. It's 2 times 6. That's a prime. 6 is 2 times 3. Those are primes. I'll come back to that. The denominator is 18. That's 2 times 9. 2's a prime. 9, 3 times 3. Those are primes. Now, I'm not going to put it in exponential notation, but I'm going to take 12/18 and I'm going to write it as 2 times 2 times 3 over 2 times 3 times 3. We know that any number over itself is equal to 1. So 2 over 2 becomes 1. 3 over 3 becomes 1. And if I multiply 1 times 2 times 1, I get 2. And if I multiply 1 times 3 times 1, I get 3. In other words, those, sometimes it's referred to as they cancel out. That's not really an appropriate word for it, but I hear it a lot. They divide it out. So this is a little shorter, but it requires your brainstorming that you came up with the common factor of 6. This one, prime factorization, divide out the common factors. So I'll employ both of those in my examples. All right, number 1, write the fraction 5/10 in lowest terms. I think most of you will see that 5 goes into the top once and 5 goes into 10 2 times. And there would be no reason to do that problem any other way. Number 2, I have 4x over 26. Does the variable x make this a lot harder? The answer is actually no, it does not. Let's take a look at the numbers first. Can you think of something that will go into both 4 and 26? Well, since they're both even, 2 will. So I'll just think about that. 2 will go into 4 2 times, keep the x. 2 will go into 26 13 times. Sometimes people write it like this. 2 goes in there 2 times, 2 goes in there 13 times. Don't forget the x. Now, is there a common x? Is there another x to divide out with that one? And the answer is no. So we're done. All right, number 3. I have 24 over 28. Now, on this one, you might not need this at all, but just in case, prime factorization of 24. Well, it's 2 times 12. Prime. 12 is 2 times 6. Prime. 6 is 2 times 3. Primes. So the numerator is 2 times 2 times 2 times 3 over the denominator of 28. I'm thinking 4 times 7. 4 is not a prime. It's 2 times 2. Those are primes. 7, it's a prime. So it's 2 times 2 times 7. Yes, I know I probably did that kind of quickly, but you can think through those prime factors. Divide out your common. 2 and 2, 2 and 2. I think that's all we've got. So what do I have left on the top? I have 6. On the bottom, I have 7. This is 6/7. Another way we could have done that is if you looked at these and identified the number 4. 4 goes into 24 6 times. 4 goes into 28 7 times. And you can get 6/7 much faster if you identified the 4. All right, next one, 20 over 50. What will go into both of those? Well, I hope you think the number 10 because they have trailing zeros. So when you divide by 10, it takes off the trailing 0, and you're left with 2/5. Okay, let's take a look at the next one, and we're going to start involving variables a little bit here. Again, I have 42x over 63x. All right, the numbers. What number will go into 42 and 63? If you're pretty good with your multiplication facts, then I think you will recognize that 7 will. 7 goes into 42 6 times, and 7 goes into 63 9 times. You have x's. Well, that's a common x, which means it divides out. If you can see through my clutter, I have 6 over 9. And looking at that, I realize that's not in lowest terms yet. It's better, but it's not all the way, because there's a common factor of 3. 3 goes into 6 2 times, 3 goes into 9 3 times, and this is 2/3. What that means is I divided by a 7, then I divided by a 3. The greatest common factor, which I did not see to start with, was 21. 7 times 3. 21 went into 42 2 times. 21 went into 63 3 times. The x is still divided out. You might have chosen prime factors instead. All right, number 6. Well, one thing I want to make sure I do is put a negative with this, because whether you're in higher terms or lower terms, the sign of the fraction doesn't change. Let's do prime factorizations. 54. It's an even number. 2 goes in there 27 times. All right, 2 doesn't work anymore, but 3 does. 3 goes in there 9 times. That's a prime. And 9 is 3 times 3. So the prime factorization of 54 is 2 times 3 times 3 times 3 over. Let's take 117. Well, I know 2 doesn't go into it. Does 3? Well, 1 plus 1 is 2, plus 7 is 9. So yes, because the sum of the digits is divisible by 3, this number is divisible by 3. So 117 divided by 3 is 39, and that's a prime. 3 goes into 39 13 times. 13 is a prime. So the denominator is 3 times 3 times 13. Dividing out the common 3 and the other common 3, what do I have? I'm back up here with my negative sign. I have 2 times 3 is 6, and I have a 13 left in the bottom. When I divide these out, many times I forget to write it, but there are little ones left behind. But multiplication by 1 is the identity, and it doesn't change anything. All right, let's take a look at number 7. I have 8x squared over 20x. Let's take care of the numbers first. What will go into both 8 and 20? Well, 4 will. 4 goes into 8 2 times. 4 goes into 20 5 times. So this problem has become 2x squared over 5x. Now, when you start involving exponents with your variables, you might want to expand it. 2x squared is 2 times x over 5x. Common factor of x, and your answer in lowest terms is 2x over 5. So I take care of the numbers like I always have. With the variables, sometimes they expand them because it makes it easier to do. Let's see that in the next one. I have 55 x to the third y to the second over 44 xy. What will go into 55 and 44? I think everybody will see that 11 will. 11 goes in there 5 times, 11 goes in there 4 times. So I have 5 x y over 4xy. Divide out the common variables, x, y, and I get 5. X will be written as x squared with a single y, and it's over 4. You may see that you don't really need to do this physical expanding, but I am in the notes. All right, the last one. I have 255, goodness, a to the fourth, b to the third, c to the fourth, over 17a, b to the third, c to the fourth. Excuse me. Well, I'm just going to make a guess here. I know 17 is a prime number. So I'm going to grab my calculator and take 255 and see if 17 goes into it evenly. And sure enough, it does. 17 goes into 255 15 times, and it goes into itself once. Now, do you need to expand these variables? Well, you can, and I will in just a minute. But many people would see c to the fourth, c to the fourth, those divide out. B to the third, b to the third, those divide out. Now what about the a's? You've got a to the fourth over a. The a on bottom knocks out one of those a's, leaving you with a to the third. Now for me, the hardest thing about this is seeing what I have left after all my clutter. All right, I have 15 a to the third, and on the bottom all I have is 1, and I don't write a denominator of 1. Now I will go back for our variables, and we had 15 a to the fourth, a, b to the third, b, b to the third, which was b, c to the fourth, c, over implied 1, a, b, c. Now you'll see that we probably didn't need to do this. Can't divide. These b's are gone, and one of the a's. What does that leave you with? 15 a to the third. Okay, so expand it if it's helpful, and if you don't need to, that's fine. You can identify a common factor and divide it in, or you can use prime factorizations. So there are several ways, and if you want to go back to a previous lesson and make sure that you understand your divisibility test, because those will be helpful.